let's jump into a few examples on thermal energy. All right, so if you're just getting introduced to this topic, I'm going to do 3 examples in here. So here's the first one. It's more kind of a qualitative example. So you have 2 identical substances with the same mass at the same temperature. How much heat would you observe if the 2 would be placed in contact with each other? So how much transfer, okay, of thermal energy would you or would we see, okay, kind of going from one object to another? Well, the answer is 0, none. So if you have 2 identical substances, they're exactly the same mass, the same temperatures, so the specific heat capacities would be identical, so there isn't really any transfer, on average, of course, that you would see. So that is it, okay? So the answer for this one is that you basically, all you would see is 0, okay? So on average, that's what we would see. That's the first example for you. Here's our second example. So this one is basically conversion, getting you comfortable in converting between degrees Celsius, kind of Kelvin and Fahrenheit. So as you go back and forth in between them. So there's 4 conversions. And once you know what the actual equations are, so here's the first one. Okay, this is between degrees Celsius and Kelvin. And then here's the second one that you have in here. So that's between Celsius and Fahrenheit. Then you can convert between anything you like. Now, of course, sometimes we'll forget these formulas, so you can take a look at them, okay, and refresh yourselves. But once you have them, this isn't really that super difficult, okay? So let's give it a try. So here is A, okay? So we want to take 27.2 Fahrenheit into Celsius. All right, so I'm going to use, okay, that equation number 2. Let's call this one 1. Let's call this one number 2. So if I want to do that, so that means I'm just simply going to substitute back in here. So it's going to be 27.2 minus 32, and then I'll get exactly what the answer is. All right, so let me take out the calculator. In here, we have, so 5 over 9 multiplied by, let me be careful there, and in brackets, 27.2 minus 32 equals, and there you have it. So this is going to be negative 2.6, and that's going to be degrees Celsius. Okay, continued, if you want to try to keep this kind of to the same number of significant figures, okay, so we would keep it into 3, so this would have been 2, 6, 7 degrees Celsius. All right, so that's part A. Now let's take a look. So for part B, so this one is from Celsius to Kelvin, so we're going to use the first equation. So this one is not very difficult at all. So if I substitute, so I'm going to get 8.2 is equal to, this is in Kelvin, minus 273. So really this just shifts over, okay, or gets added into that. So you would have 8.2 plus the 273, and that's all that you would have. So TK, right, or the temperature in Kelvin would have been 281, okay, 0.2, and that's what we would have Kelvin, or if you want to keep to the same number of sig figs, it would have been 280 Kelvin. All right, so that's for part B. Now let's take a look at part C. So part C might be a little bit more work. So this one is 35 Celsius, and we want to get into Fahrenheit. Okay, so it's not that much more work. Okay, so let's plug it in. So this is 35, that's degrees Celsius, is equal to, so 5 over 9. And then T, I'll just put F minus 32. So we just have to solve this equation for TF. All right, so we can multiply both sides, so that 5 over 9, so if you multiply both sides by 9 over 5, that's going to get rid of this, okay, from that side. And then let's take a look, okay, what we will have. So 9 multiplied by 35 divided by 5, it's actually 63, is equal to, so TF minus 32. So take that 32 over on the other side, and you're going to get that TF is equal to, so my answer plus 32, which is 95. All right, so that's Fahrenheit, and this is already to 2 significant figures. Okay, so there you have it. Okay, so now part D of this question. So let's take a look there. So 327 Kelvin to Fahrenheit. Okay, so now this is going to be a little bit more work, okay, in here. So if you take equation number 1, So what I'm going to do is we can change the Kelvin to degrees Celsius, right? So that's something that we can very easily do from equation number 1. So in fact, I can do that right off the bat. So 327, as I substitute it in, minus 273 is going to give me 54 Celsius. And now once I have Celsius, okay, then I can substitute it back into here, and then I can solve for TF. So basically it would be more or less like the question that we have just done. So this is going to be 54 is equal to, so 5 over 9 TF minus 32. So you saw in the previous example how you can approach that. All right, so that means I can take my 54. All right, so let's multiply it by 9, okay, divided by 5. So we'll get this, which is 97.2 equals, so that's TF minus 32. So all I have done is I basically multiplied both sides by this. All right. Okay, so that's what we have. So 97.2, and then bring that 32 over on the other side. And we're going to get that TF is equal to 129.2. And we started off with 3 sig figs, so we can keep this to 3 sig figs, 129. All right, so Fahrenheit. And that's what you would have right there. All right, so those are the examples in terms of converting and getting comfortable with moving temperatures back and forth. All right, so that is it for this one. Here's the last example. So we want to do some more conversions. Now this is for units of energy, and we're going to assume that 1 calorie is equal to 4.184 joules. So that actually comes from the fact, so by the way, so if you take a look at calories, so this one right here, so this is, if you took 1 milliliter, around 1 gram of water, and you tried to raise its temperature by 1 degree Celsius, it would come out to 4.184 joules. And we've named that as a calorie. And notice that it's a small calorie, okay, right here. So the ones that we typically are used to are capital calories. Those are kind of coming from food. And those ones are equivalent to kilocalories, which means, 1,000 times of these, right? So that's why you have these 2 given to us. All right, so here's the other conversion ratios. Okay, so let's try all of these. So for part A, we have 279 calories to joules. So we have 279, this is calories. If you want to convert this back to joules, so again, so this is not very difficult. So we have 1 calorie, this is 4184 joules, so the calories cancel. And we can find out that this is 279 multiplied by 4184 equals, all right, so it's a monstrous amount, okay, in there. And this is, these are the capital calories that we have. So it's 1167336. And if you want to keep the same number of sig figs, so 3, meaning, so 1170000 joules. Okay, so it's quite a lot of joules in there in terms of calories. And indeed, because these are capitals, right? So that's what we would have. So 1 calorie is actually quite a bit, okay, of energy. All right, so for part B, so now we have 178,225 joules. Now this one we want to change into the small calories. All right, so that is now 4.184 joules, okay, for the small calorie right there. So this is not the capital calorie, which is kind of food calories. So 178,225, and then divide this by 4.184 equals, and that's going to give us, okay, our answer, which is 42,596. Okay, let's see. At 1, 2, 3, 4, 5, 6. Okay, that's 6 actually significant figures. So I'm going to round this to 0.8. So that's 1, 2, 3, 4, 5, 6. All right. That's how many small calories we would have in there from that. All right, so that's part B. Okay, part C. So this is kind of just gets you used to getting familiar with these. So notice it says, okay, kilocalories, and we want to change this to kilojoules. So this is the same thing as saying 2.8 calorie, all right? So this K in front with a small c is the same thing as capitalizing. So now we want this to kilojoules right there. So we can certainly change this back to joules. So 1 calorie is 4184 joules. So that's going to get rid of that. And then we can certainly just move the decimal place, okay, if needed, because it's kilo, it's going to be 3 times. So 2.8 multiplied by 4, 184. All right, so that's what we would have. 11715.2, but this is joules. So if you want kilojoules, so now you're going to be moving this 1, 2, 3, which is 11.715 to kilojoules. And I guess this is 2 sig figs, so this would have been 12 kilojoules as my answer. All right, so that's another one. Okay, so let's see what else they give us. So part D, a patient reads a food label and notices that the item carries 180 calories. How many kilojoules is that? Okay, well, this is exactly the same thing. So D, all right, and now what I'm going to do is, I'm actually going to try to just show you in here. So notice that it says that 1 calorie is equal to 4184 joules. Or in other words, it equals to 4.184 kilojoules. Okay, so if you're given this, you can certainly use this as your ratio in terms of your conversions, and I'm going to use that so that I don't have to necessarily kind of move the decimal at the end over here. Okay, so that's what I'm going to do. So this is 180 calories, and I want to change this back, so I want to get rid of calories, and that's 4.184 kilojoules. That's what I just showed you. So we can take that 180 multiplied by 4.184, and there you have it. So two significant figures, so I'll do it right away actually. Okay, that's how many kilojoules you would have. All right, so that's for part D. Now for part E, okay, so this one is kind of cool. So you have a medical procedure, okay, and it uses 1.8 kilowatt hours. So how many calories is that? 1.8 kilowatt hours. All right, so this one's E. 1.8 kilowatt hours. So this kind of forces you back in, combining power and energies together in terms of units. So first off, so kilowatt, so this is 1.8 really like kilojoules, right? So that's the kilojoules per second, because a watt is joules per second. Now the hour, of course, 1 hour is equal to 60 minutes, and this equals to, okay, so 1 minute is equal to 60 seconds, which means that 1 hour is 3,600 seconds. Okay, so that's what we would have there. So we can get rid of those seconds there. Now this is 1 hour, right? So this is going to be 3600 seconds. That's equivalent to 1 hour from right here. Then they want this in calories. So the seconds are gone. Notice I put it into kilojoules. So now I have to get rid of the kilojoules. And 1 capital calorie is 4.184 kilojoules. And that's what I just did in the previous example and explained over here. All right, so that's what you saw right there. So that is it. So now let's punch all of this in the calculator. So 1.8 times 3600, and then divided by 4.184, and there we have it. All right, so that's what we would have in there. So those kilojoules cancel, and we would have 1548. Well, okay, so two significant figures, 1500. That's what we would have in kilojoules. All right, so kilowatt hours, okay, is about that. Okay, so that is it for this example, and it completes, okay, the kind of introductory questions that I wanted to throw at you in the beginning. So some conversions, okay, and a little bit about heat transfer. Okay, thanks for watching. See you in future video. Bye, everybody.